Hello, welcome to my channel. In this video, I'm going to be teaching you the laws of fractional indices. Now, there are two basic laws of fractional indices I need you to take note of. The first one is negative indices, which can be written as a to the power of negative n is equal to 1 over a to the power of n. Now let's use this law to solve some examples. Let's say we are supposed to simplify a to the power of minus 1 or negative 1. Now how will we simplify this? Now you see in the law a is here, and in the expression a is also here. So what we are going to do is to follow this law, and therefore we're going to have a to the power of negative 1 is 1 over a to the power of 1. Now anything to the power of 1 is that same thing, so it's okay if we remove this one. So we're going to have 1 over a, and this is our answer. Now for instance, if this 1 were to be 2, if this negative 2 was here instead, in that case we'll have a to the power of negative 2 would be 1 over a to the power of 2. So this is the answer. Let's try another one. If we have, let's say we have 5 to the power of negative 3. Now in this question, 5 is representing a and negative 3 is representing negative n. So what we'll have here is 5 to the power of negative 3 is 1 over 5 to the power of 3. Now this is equal to 1 over 5 to the power of 3 is 5 times 5 times 5, which is equal to 125. So this is the answer. Now try to solve this example. If we have p q raised to the power of negative 2, try to simplify this expression. Now is it going to be p q, or rather 1 over pq squared? Well, this answer is wrong if this was your answer. Now what you are supposed to do is take note that pq is p times q. That is one thing you should take note of. And pq to the power of negative 2 is p times q to the power of negative 2. So we are going to apply the negative indices law to this part of the expression, and if we follow this law where q is representing a, we are going to have p times 1 over q squared. And this is equal to p over q squared. So this is the answer. Now let's try this AB to the power of -5. Now try to solve this or simplify this expression by yourself. Now in our previous example we saw that PQ to the power of -2 was P times Q to the power of -2. So we are going to apply that same knowledge here. So this is equal to A times B to the power of -5, and it's equal to A times 1 over B to the power of 5, and this is equal to A over B to the power of 5, and this is your answer. Now let's go to the second law of fractional indices. But before that, I want you to take note of this. If we have the square root of x, now the square root of x is equal to x to the power of 1 over 2. And this can also be written as the second root of x. Now this and this, they are the same thing. Now some might choose to ignore the 2 while some might choose to add it. It's basically the same thing. But if we have x to the power of 1 over 3, this is equal to the third root of x. And if we have x to the power of 1 over 4, this is equal to the fourth root of x. Now what this means is that if we have the square root of x, is simply a number that will multiply itself twice to give you x. So therefore the third root of x is a number that will multiply itself 3 times to give you x, and the fourth root is a number that will multiply itself 4 times to give you a given number. So if we have, for instance, the fourth root of 16. Now the fourth root of 16 is a number that will multiply itself 4 times to give you 16, and that number is 2. 2 multiplying itself 4 times, or 2 to the power of 4, is equal to 16. And let's say we have something like x to the power of 2 over 3. Now what this means is that, or you can write this as the third root of x. Now this 2 is going to represent the power of x, since x squared can be written as x raised to the power of 2 over 1. So this will be the third root of x squared. Now, which brings us to the law, which can be written as a to the power of m over n is equal to the n roots of a to the power of n, which can also be written as the n roots of a, all in brackets, to the power of m. Now let's use this to solve some examples. If we have 25 to the power of 1 over 2. Now remember what I said, that 1 over 2 can also be said to be the square root of the number, or a number to the power of 1 over 2 is the square root of the number. So this is equal to the square root of 25, or you can call it the second root. Now the second root of 25 is 5, since 5 times 5 is 25. And this is your answer. Now let's say if we have x to the power of 5 over 4. Now feel free to pause and work on this example by yourself. Now remember what I said, when we have something like this, the denominator will be the roots and the numerator will be the power. So what you are going to have is x, or the fourth root of x to the power of 5. Or you can choose to write it in this form. So you have the fourth root of x, all in brackets, to the power of 5. So here is your answer. Now let's say we have 8 to the power of 2 over 3. Now this will be equal to the third root of 8, all in brackets, squared. The third root of 8 is 2. So we are going to have 2 in brackets raised to the power of 2. And 2 to the power of 2 is 4. So this is your answer. And let's try this example. If we have y to the power of negative 2 over 3. Now note, in this particular example, or in this particular problem, we are going to apply the law of negative indices. So feel free to pause the video and try out this example. Now, what we did when we are dealing with negative indices was that when we have a letter or a number raised to the power of a negative number, what we do is to write 1 over that number, then take away the negative symbol from the power. So we are going to have 1 over y to the power of 2 over 3. And this will be 1 over the third root of y all in brackets squared. So this is the answer. Now let's try this example. If we have 3a to the power of negative 1 over 3. I'll try to work on this example by yourself. Now, in the previous law I was teaching or discussing, I said that whenever you have 3 or 2 figures attached to each other, it simply means that it's going to be one of the figure multiplied by the other figure, which is, in this case, it will be 3 times a to the power of negative 1 over 3. And this will be 3 times 1 over a to the power of 1 over 3. Now we will apply this law right here. So this will be 3 times 1 over, now this will be the third root of a, since the denominator of the fraction is, of the power fraction is 3. So it will be the third root of a. Now you can choose to add the power of 1, or you can choose to leave it. So this will be equal to 3 over the third root of a. So gives the answer. Now let's try this example. If we have 2 to the power of 3 times 1 over 6 to the power of negative 1. Now try to work on this example by yourself. So in this case, what we are going to do is take the cube of 2, which is 2 to the power of 3, that is 8, times, then we are going to apply negative indices here. This will be 1 over 6. Now we can choose to leave this 1 out of it. So what we are going to have here is, we have 1 dividing a fraction. Now note, this fraction came on its own, and since we are going to have to simplify this, we are going to have 8 times 1. You can see this 1 at the top as 1 over 1, 1 over 1 divided by the fraction at the bottom, which is 1/6. Now in maths, when you have an expression like this, what you do is to convert this division sign to multiplication sign by inverting the fraction at the right hand side. So we are going to have 8 times 1/1 times 6. We can write 6 or 6/1, it's the same thing. Now 8 times 1 is 8, and 8 times 6 is 48. So what you are going to have here is 48. So this is our answer. Thanks for watching. Please don't forget to like and subscribe, and please, if you need more examples on indices, please check out my next video on more problems involving indices, where I'll be solving more complex problems. Please don't forget to share to who you may think might have problem with this particular topic. So thanks for watching.